Hey everybody, Andrew again. And in this video, we are going to be examining question number 30 from the math test inside test 2 in your red book. So turn to test 2, look at the math test, go to question number 30, read the question, and then hit play when you've done so. Great. Now in this question, this is a classic ACT math test question. On almost every single ACT math test that you're going to take, you will see a question like this. I like to call these the shaded region questions. You'll see a shaded region question in tons of ACT math tests. We're going to approach it like any other question, but I'll show you kind of the general way to crack the code on these questions. We're going to, first thing you're going to notice, first of all, is that we are dealing with a word problem. So of course, we're going to deal with our favorite code cracker, the word problem strategy. So we're going to attack this as a word problem. And as always, we ask ourselves, step number 1, what am I trying to find? And in the last piece of the word problem, down at the bottom of that paragraph, it says that we are looking for the area of the shaded region. Step 2, we ask ourselves, what do I know? Well, here they give us pretty much everything that we know in this picture. I just kind of redrew the picture that's in the book. It basically gives us this picture, and it tells us that this 10 is the diameter of the smaller circle, and this 10 is the radius of the larger circle. And with that information, we need to move on to step 3, solve the problem, and find the area of this shaded region. Now here's where I'm going to show you how to kind of crack the code on any shaded region problem. The way that you solve any of these shaded region problems, whether it's a triangle inside of a square, or a square inside of a hexagon, or a triangle inside of a circle, no matter what shape is inside any other shape, there's one pattern that you need to follow to answer these questions. And here's what it is. I'm going to write it down here. All you have to do to solve any shaded region problem is take the area of the big shape minus the area of the small shape. So that's exactly what we're going to do here. We're going to take the area of the big shape, which is our big circle, minus the area of our small shape, which is our small circle. Now, how do we find the area of a circle? Just a quick refresher. The area, I'll put a little circle here so you know it's the area formula for a circle is pi times the circle's radius squared. So let's use this formula, the area of the big shape minus the area of the small shape, along with the area formula for a circle to solve this problem. Let's start by finding the area of our big shape, okay? So the big shape is this large outer circle. And the problem tells us that this 10 here is actually the radius of this larger circle. So the area of our larger circle is pi times the radius, which is 10, squared. And if we square 10, this is the same thing as 100 pi. Now, next thing, we need to subtract the area of our smaller shape. Our smaller shape is this small circle. And if the diameter of the small circle is 10, that means the radius must be 5, because the radius is always half of the diameter. So the radius of this circle is 5, which means that the area of this small circle is pi times the radius, which is 5, squared. 5 squared is 25, so this is the same thing as 25 pi. So the area of the big shape minus the area of the small shape to find the area of the shaded region is 100 pi minus 25 pi, which leaves us with 75 pi. And 75 pi is answer choice K. So K is the answer to this question.